In this Dr. T's Research Methods Basics video, we're going to talk about the standard and normal probability distributions. Now, a normal distribution is a continuous probability distribution for a random variable. We'll call it x. The graph of a normal distribution is a normal curve. What does this mean? Well, let me give you a couple of remarks about some symbols that we use all the time in statistics. And the first we call mu. And mu is the population mean. We've used x bar several times in examples. X bar is the sample mean. And when we see sigma, this is our population standard deviation. All right, so I'm going to draw out a normal probability distribution as I give you kind of the characteristics and the guidelines for a normal distribution, probability distribution. All right, I'm going to start out here with just the x-axis. Okay, there's our x-axis. Now, the first characteristic of a normal distribution is that the population, or the sample, mean, median, and mode are the same. The mean, median, and mode are the same. The next characteristic is that the curve, the normal curve, is symmetrical about the mean. All right, so you are going to learn what a bad artist I am, but here's a curve. See how symmetric we can make it. Well, not terrible. Imagine it perfect. All right, so it's symmetric about the mean, meaning there's about as much room on this side of the mean as there is on this side. Not symmetric enough, but we can pretend. Okay, it's symmetric by the mean. And then we have standard deviations above and below the mean. And again, the standard deviation really is just telling us how far our observations vary from the mean. When we're looking at a population probability distribution, you can use sigma. And so right about here is, well, here is what I want to be mu. There's our population mean. And this first line is mu, the mean, plus sigma, one standard deviation above the mean. This line over here is mu minus one standard deviation. So it's one standard deviation below the mean. An important characteristic of a normal probability distribution is this. The tails here will come close to the x-axis, will come close to x-axis but never actually touch the x-axis. So both sides will come close. This curve comes close, but never touches. And probably one more kind of awesome characteristic is that the area beneath the curve, is always equal to 1. Why? Well, think about what you know about probability distributions, right? If an empirical probability ranges from 0, not a chance in really, really hot weather that some event is going to occur, and 1, it's absolutely going to occur, and we think about what a lot of our probabilities are, which is really just a relative frequency, then all of those probabilities added up are 100%. 100% of whatever data we're looking at, and if we're looking at a population, 100% of the observations for a variable, the probability of them occurring or not occurring is going to fit under this curve, and they're all going to equal when you sum them together. So the sum of all probability of x is equal to 1 under this curve. Now, when we're talking about the normal probability distribution, it's important that we really kind of solidify, at least in our minds, what a standard deviation is telling us. So I'm going to draw this out in a couple of ways with the normal curves, because normal curves, the normal probability distribution, can have any mean and any positive standard deviation. It's really these two parameters, mu, the population mean, and sigma, the standard deviation, that determine the shape or what the normal curve looks like. So let's go ahead, and I'm going to create what I'm calling a scatter plot, where I'm going to plot out different values of an x variable, any x variable, and we're going to say that this is the entire population worth of data points. And let's see, if I'm looking for the mean in all of these points, well, I guess it would probably be out here. And we're going to go ahead and we'll just label this mu, population mean. Well, what the standard deviation is really telling us is how far away from mu we expect these observations to be. Right? So we'll call kind of the space between there is sigma. Or the standard deviation. Let me draw another one for you. Okay, so here's one, and here's another. Plot out some points for you. Call it our population. And the population mean for these points is probably right in here. And you can see that the standard deviation for, we'll label these plot 2. The standard deviation for plot 2 is much smaller overall than it was for plot 1. So when I go to draw out a graph of each of these probability distributions, the shapes are going to be different. It really, knowing what the mean or the population mean is gives us a starting place, right? So I'm just going to make numbers up here since I didn't put numbers up in my scatter. But we'll say that the population mean for plot 1, or you could have made it a table, is 3.5. Okay? And our standard deviation is 1.5. Well, that's pretty, I mean, it's sizable, I suppose. And I think this is pretty close to what it might look like if this is how we were to kind of understand it. You could have, you know, our 0 here, 1, 2, 3. All right, so that'd be the first plot, the first population. And for the second one, oh, let's see. I guess our mean for this one, well, let's make it the same. Our mu on this one is going to equal 3.5. But this time our standard deviation is, oh, let's say it's smaller than 1. Let's say it's like 0.7. Okay, I'll do the same kind of thing here. And our mu is this 3.5 point. There we go. But our standard deviation is less than 1, so that would make this curve more like that. Simply because our points aren't that far from the mean, the majority of our points, right? So you just have to notice that even though they may have the same mean and they're normal curves, the standard deviations are what are determining the different shapes here. So what then is a standard normal probability distribution? Well, this is just a little bit of a teaser, but a second ago I showed you different graphs of normal probability distributions that were very different because even though their means were the same, the standard deviations were different. That can make things kind of tricky sometimes. So we basically will standardize a normal distribution, and in a standard normal probability distribution, the mean is always equal to 0, and the standard deviation always equal to 1. Standardizing.